So next up in the Earth system, let's look at how natural processes have changed the Earth system and of course the climate, because our goal here in this course is to learn about climate, but climate and Earth and life actually have all evolved together. In the sense, life evolves. What happens? It begins to change the carbon dioxide, because when lots of plants evolve, they begin to take up carbon dioxide. And what happens if you reduce the carbon dioxide in the atmosphere? You reduce the greenhouse effect and you let more thermal energy go to space. In fact, they evolved so fast during the past geological periods. I use the word period a little bit carelessly, because geologists are very strict about their eons, their eras, their periods and so on. So when plants evolved, they took down so much carbon dioxide that the earth cooled and went into a frozen state. Okay, so just remember, and these things happen. So before we move to the Earth system and how geology, the natural processes, have changed climate, let's use the example of the dinosaurs, because everybody loves dinosaurs, right? So I took some pictures from the Natural History Museum of the UK, and it shows some volcano here being active in the back, obviously harmlessly fuming out some smoke plume, and there are these different types of vegetation. Dinosaurs existed some 250 million years ago to as recent as 65 million years ago. When you talk about geology of the earth, it evolved 4.6 billion years ago. That's a long time ago. So when you think of that long period, dinosaurs are very recent. In fact, the human beings evolved just like this, just an instant ago, if you think about the time period over which Earth has evolved, life has evolved, and how geology has evolved. Okay, I think you all know how the dinosaurs went extinct. The best theory we have is that a big meteorite crashed into Earth, and we know where it crashed because it left a huge impact crater. When something big hits the Earth, it damages the crust of the Earth and leaves what is called a impact crater, which is in the Gulf of Mexico, Chicxulub. I don't know how it's pronounced, Chicxulub maybe. You can go and find it, but maybe you already heard of it. There is an image from the European Space Agency showing the crash of a meteorite and the plume of water, dust and lava that would emerge, because the impact would be so large that it would burst through the Earth's crust and release. It will be like a volcano going off, except that you are doing that by crashing a big object into Earth. And there's a lot of theories about how the dinosaurs actually went extinct. Did they go extinct because of the impact, or because of the dust that got thrown out into the atmosphere and blocked all the sunlight, all the vegetation died, and maybe they starved, or maybe lots of viruses evolved and they began to give diseases to the dinosaurs, and so on and so forth. So what am I saying? I'm saying long time ago a lot of things happened, and we talk about theories and crash of a meteorite. This is like detective work. Okay, you can have detectives working on how the Earth has moved the plates. Remember, all the continents are kind of plates: Australia, Asia, Europe, North America, South America, and they move. They are floating on the magma below, and they float around and they move. They were all together in the south many 100 million years ago. They have been moving north. They still continue to move north, as we mentioned before. India, for example, came from south of the equator, moved across the equator into the Asian plate maybe some 30 million years ago, continues to push into the Asian plate, subducts or goes under and pushes up the Asian plate, which is what created the Himalayas, right? The Himalayan mountains were created by India crashing into Asia. Of course, if you create such a big mountain and you build snow on top and you block the winds and so on, you begin to change the climate as well. Okay, so that's how things happen. So on geologic time scale, you can say this is late Jurassic, 152 million years ago. I take these figures from the good people of Encyclopedia Britannica. It's available online, so I'm assuming it's allowed to be used. Thank you. I'm just using them for teaching freely, so don't come after me. So you can see that the place here is what is current North America 152 million years ago. It's sitting there. There is the semblance of a Pacific Ocean, but you can see the oceans were different back then. India was down here in the south, and Australia was down here, Antarctica is still there, and continents were named differently. There's something called Gondwana, which is a mix of South America and Africa and North America here. Laurasia and Europe in its past form is here, and Turkey, Iran, North China, South China, and so the Asian plate looked very different. Oceans looked different, which means climate and albedo and the circulation would all have been different. So you can imagine everything was different. So these are the mountains of that time here in dark brown colors. Land, which is just the lower levels, shallow seas, so less than, let's say, 200 meters or so. It matters for life. Deep ocean basins here in darker blues, and so on and so forth. Okay, so plates move around. When did we figure this out? Only in the 1920s. Very recent. You are very young. For you it's a long time ago, but for me it's very recent. How old am I? Not that old, but Alfred Wegener was the first one to look at the map carefully of the current configuration. I don't have a map here, but look at North America, South America, Europe and Africa and move them together. Seemed like they fit together like a piece of a jigsaw puzzle. He looked at it and proposed that maybe the continents are not fixed, maybe they move. People, he was a scientist, he was a geologist. People laughed at him and said, "What are you talking about? How can plates move?" And only decades later it turned out he was right, and by then unfortunately he had died. So don't be afraid of suggesting crazy things. If you have some evidence for it, people may not believe you, but you keep at it, and you discover new things, and it's fun. Right? So this is how climate can change because of geology. Coming back to the Earth system, we have our sun again, our energy, we have our water cycle, evaporation, cloud forming, rain, rivers, snow, and so on. So we have our Earth system in the back again with the ocean, land, humans, volcanoes, mountains, and so on. We have our circulation, winds. Now we are adding water temperature, we are adding ocean circulation, and we are changing the distribution of the continents and the oceans, just like we did here. When you build a computer model, you can do that in the model. You can just take North America and move it somewhere. You can sink the mountains because it's all like a virtual reality. And then you can see how the oceans change, how the energy balance changes, how the winds change, where the snow falls, where rain happens, and so on and so forth. So we still have energy balance. So you have changes in albedo, the thermal energy is changed because of that, and then you have mountain building happening. So you have a new mountain forming, which if we look before we had there, so let's say there is something subtle here. It's showing some bands of colors. As mountains rise, they bring up different material from the ocean, and they are at different times in the past. So they have different structures, different chemicals in them, different muds in them. It could be because of the biology, it could be because of the geology, and so on and so forth. All sounds very complicated, but imagine this is the detective work. You find evidence from the past, you sit in a lab, you do a lot of work, a lot of chemical analysis, you do a lot of physical analysis, and so on, and you figure out when did this mountain come up. So we know Himalayas came up from about 30 million years ago to maybe 10 million years ago. India still continues to move north at about, I think, 3 centimeters per year or so. And the Himalayas continue to rise in maybe about 1 centimeter per year or so. We can use now GPSs and all these things to figure out how to do these things, to measure these small changes. Remember, the Mount Everest is almost 30,000 feet high, and we are just measuring a small change in its height using GPS and so on. So geology has been happening. It still happens because, as we said, India is moving north. Australia is moving north as well. Remember that Australia was way down here and is now sitting somewhere here, and this configuration of the Indian Ocean and the Pacific Ocean has changed because of the Indonesian islands over here, and so on and so forth. All those things change the energy balance, the albedo, the mountains, the winds, the reflectivity of the sun, the circulation in the ocean, and life everywhere has also changed in response to these things. Okay, so it's pretty amazing that geology is a natural process that keeps changing climate, and it's still happening in the background, but now we are going to look at how humans are changing the climate at a very fast time scale as well. Okay, so we'll continue with the Earth system and add a few details about human impacts on climate, which is what the main focus is here, because we're talking about climate change, which in this context mostly means human induced, human caused, human created climate change. Okay, so we'll come back and continue. But to understand that humans are changing climate, you must know how the climate has behaved in the past. This is what this is about, and this is called paleoclimate. P-A-L-E-O, and there is more complicated spellings if you go to clear, pure English. But paleoclimate means past climate. There are many exciting ways in which past climates leave their signatures in the corals, in the ocean, in the lakes, in the mountains, in the trees. So we'll look briefly at the next chapter about how detectives go looking for these signals of past climate changes. Okay, so we'll come back and look briefly at the Earth system under human impact. Okay, see you in the next